Now, graphical methods was the easy method. It's very simple and straightforward. You just replace in f of x and you're going to show that you're going to find that there's a change in sign, and tada, your question is solved. Iterative methods is a bit more tricky, but again, it's very easy. Why is that? Well, as we said, this is the third part of our tutorial and we're discussing the iteration method. Now, what is iteration to start with? Okay, so iteration is also called successive approximation. And why is it called successive approximation? Because you're doing something successively, something that goes in an order after each other, and it's an approximation. You don't get an exact value, you're just getting an estimate, because it's going to be something like 5 decimal places, etc. So it's a problem-solving or computational method in which succession of approximations, each building on the one preceding, is used to achieve a desired degree of accuracy. And in order to solve an equation of the form f of x equal to 0, which is what we're doing, trying to find a root by an iterative method, you're going to rearrange here. If you want to find f of x equal to 0, you're rearranging it in the form x equal to g of x. In other words, you are making x the subject of your formula, and it's going to equal again a function in the terms of x. And why is that? Because it's going to give you xn plus 1 equals to g of xn. In other words, one value of x is going to build on to give you another value of x that is greater than it by 1. So in how you get it is, okay, this might sound weird, but let's just take an example and it will explain. The sort of questions you get is, here I'm solving a question from the past paper, so if you want to keep track, this is June 11, and I'm doing question 2. The question says, first of all, f of x equals to 2 sine of x squared plus x minus 2, and the domain is given to be x is between 0 and 2 pi, because there's sine and such. So the first part of the equation tells you that show that f of x of 0 has a root between 0.75 and 0.85. So root where 0.75 and it's greater than that and less than that. So as we said, this is just the graphical method. What we do is we're going to simply say that f of 0.75 is going to give us a value, which is your 0.183 by the way, and f of 0.85 is going to give us a value, which is 0.175. Then we're going to say there f of x changed sign between the change sign in the interval, and that means that there's a root. This is our important statement. Now, then we're going to solve it using the iterative formula. What they said is, this is how you get it. They actually give you the iterative formula and they tell you where to start from. So they tell you that f of x equal to 0 can be written as x equal to arc sine. So it's sine inverse of 1 minus 0.5 xn, and all that is to the power half, or just radical. And they give you that x of 0 is equal to 0.8. So this is this is by the way xn plus 1. So they give you this formula here, and this is called the iteration formula. It is given to you. It's given to you where to start from, and they're going to tell you find x1, x2, x3, and they give you certain approximation. So here they set to 5 decimal places. 5 decimal places, and they ask you to find x1, x2, x3. So what you're simply doing is you want to find x1, so you're going to use here sine inverse of 1 minus 0.5 of xn, which is 1 minus this, so it's x0, which is given to you here as 0.8, and then you're going to put a tab, and then you're going to find what this is equal to 5 decimal places. Then you're going to do the same for x2, and you will get 0.801133, and then you're going to do the same here, etc, 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 and you're going to get 0.167, and then you find it. After doing that, what you see is you're approximating, you're getting closer to something. You find that it's always 0.8, and then you find that this is going to be 0, this is going to stay 0, this is going to stay 0, so you know that this is also going to be 0. So this is how you do iteration. You're trying to find what it converges to. However, here in part C, what it says is that show that the alpha, also alpha by the way is what we call root usually, and they say show that it's 8.0157 to 5 decimal places. The way you show it is that you're going to say okay, so if it's correct to 5 decimal places, so it is between what? If it's between something here and here, we are going to simply add it here 157. We add another decimal place, so because we know it's not correct to 6 decimal places, but it's correct to 6, and here we know that and then we deduct a small 5 here, so it's between 65, 7 and 70 and 75. And then this is how we stated, this is how we know it's going to work. And then what we do is we simply use the graphical method to find 0.801565, and that would give you a certain number, and then you do the same for 0.801575, and that will give you a certain number. You're gonna notice that there's a change in sign. Okay, let me use shortcuts here, so you know that there's a change in sign, and thus there is a root. The root is correct. And that's the sort of questions you get on iteration. Again, it's also very simple and easy. You just follow what they tell you. In other words, it does not need any sort of rocket science. They give you the x0 or a certain x, and you're going to build on it, on it, and on it, and on it. The sort of things you can fall in is just not knowing what sine inverse is, or just not giving the correct decimal places. But nothing else is going to be very difficult for you. And that would be the part about iteration. There are more things like notes I'm going to add to you, but I'll leave that to the last part, which are our tips and tricks. So, what are these? Let's see. First of all, you need to know the rules. There are certain rules I need you to know. First one is that different rearrangements of, meaning different iteration formulas for the same f of x, so different rearrangements can give you not must give you different roots. In other words, if you have the equation here x squared minus 5x minus 3 equals 0, it can be written as x equal to radical 5x plus 3, and it can also be written as x equals to x squared minus 3 divided by 5. It can be written in both ways, but in this case, if you want to use the same x0 and you want to solve it, they can give you different roots. You can solve it and check yourself. Then, so this is one rule you need to know. Just because you have the same f of x, it doesn't necessarily give you the same root. Another thing you need to know is that different x, if I use x0 once or x1, it can also lead to different roots. And sometimes it can lead to no root at all. How do you know if there is a root or not when using the iterative method? Is, as we said here, when you looked at it, you found that yes, here it's actually it's every time you're approximating more, you're leading to more decimal places, and this is what we call converging. So when it's convergent, it's approximating something, it's going closer to a certain number, and that's when there is a root. If it's divergent, you'll find something like 0.0 and then 53 and then 300, and it just changed something. It just keeps changing. It doesn't approach anything, and that simply means there is no root. So that's how it goes. So those are like the 3 rules of iteration that you need to keep in mind, and you need to remember always to remember your formulas correctly. You know what sine inverse is, you know how to use a calculator, and you also know how to replace correctly, and you know what a decimal place is, what a significant figure is, and then you'll be good to go. The chapter is simple and easy and straightforward. Thank you.